So welcome back to Made Easy Academia. So we have in our previous discussions, we have discussed about the sequence and series as well AP. Now this morning we talk about GP, geometrical progression. So if you recall, I told you that each terms has another name that we need to master on. I told you in the previous class, I told you that whenever we have AP, it's called linear sequence. So as well, if you have geometrical progression, they can call it exponential sequence. It's still the same thing, exponential sequence. Dealing with powers. So under AP, so let's link the two together. Under AP, we talk about how to use A. We talk about the meaning of A, the meaning of N, the meaning of D as well, the meaning of T. And I told you that in some materials, on some textbooks, instead of using TN, they can use UN. So either they use UN or they use TN, the tools are the same. So if you recall, we said that when we have A is simply means the first term. That's the first one we discussed. Then as well, we say whenever we have N simply means the number of term. Then we say when we have D simply means the common difference. Then when we have TN or UN, I said is the same thing as either nth term or last term. So the only difference between the GP is that instead of having difference, in the other one we have the common difference. So instead of having common difference here, we are going to be using what we call common ratio, not common difference. Now, under the AP, these are the terms that we have. We have A, which is first term. We have M, which is number of terms. We have D, which is common difference as well. We have our TN or UN to be our nth term or last term. So all of these we also have them except the D that we have here. D here is common difference under the AP. So under the GP, instead of having what we call the common difference, we have what we call common ratio. So now let me erase this and replace it with that one. So instead of having D, we have R now. So R here, it simply means the common ratio. So at the same time, if you recall, we find, or let's say we generate more examples, many examples, so now we can find the common difference by finding the difference between either the second term and the first term, or either the third term by the second term, or either the fourth term by the third term. Similarly, here in this case also, we are going to do something like that, but it's going to be in form of ratio, in form of division. So meaning, if I want to obtain the common ratio here, I can obtain it in this way. I can say second term over first term, or we can have third term over second term, or this is our fourth term over third term, and so on. So here, for a sequence to be a geometric projections, the ratio must satisfy. They must have the same ratio. So if they have the same ratio, we can conclude that that particular sequence is a geometric progression. For example, let's say we have 2, 4, 8, 16. Let's say we have a sequence like this. Just like the way we did under the AP. So if you look at this sequence, so this is our first term, this is our second term, this is our third term as well, this is our fourth term. So now if I want to find the ratio, just like the way we did under the AP, if I want to find the ratio here, I can have the ratio to be the second term over first term, right? The second term that we have here. Or we can have it as a third term over second term, or we can have it as a fourth term over third term. Any of these that we use, they must have the same result. We are expecting to have the same values. So now, by putting this, that means I can have this one to be. So if you look at this, if you look at second term here, the second term that we have here is 4. That is 4 over 2. So if I have 4 over 2, how many 2 can we get in 4? Yeah, exactly. So 2 in 4, of course, you are going to have 2. So even if you apply the other one too as well, if you apply this third term over second term, you are still going to have the same result. How? That is the third term we have here is 8 divided by the second term we have here is 4. So 8 over 4, of course, we are going to have 2. So now if I apply this one too as well, if I apply fourth term over third term, which is 16 divided by 8, of course, we are going to have 2. Either any of the sequence that we use in that particular sequence, in that particular times. So far, if you satisfy the condition of geometric progressions, we say that sequence is a exponential sequence, and we use that one we call a common ratio, meaning we can say if it is a geometric progression, if it is a GP, T2 over T1 must be the same as third term over second term, and it must be the same as fourth term over third term. So far, if it's a exponential sequence, you don't recall under the AP we said it can only be the same if the second term minus fourth term equal to third term minus second term equal to fourth term minus third term. So any of this, that's for the AP. So for the GP now, it's going to be in form of a ratio. That's just the difference between them. Under the GP, we also have what we call the fourth term. We also have N, which is number of terms. We have R, which is common ratio. We have Tn or Un, which is called the nth term or last term. To make it more interesting, let's quickly use this method to find some terms. Maybe we are given a term, maybe in the form of either A or R or something, and we have to find the value of that particular value. We can use this knowledge of this to obtain that particular alphabet. Maybe we can that one. Note that your common ratio can be negative. It is mentioned in the other one that the common difference too can be negative or it can be positive. So here too, it can be negative, even if it can be a fraction, doesn't matter. Just follow the same process. Whatever you have, that's going to be your result. Now, or let's say we have like let's say I have like one. Let's say we have 5. Let's say we have 25. So let's say we have this GP. If I still want to find the common ratio here, we'll follow the same process, right? Yes, exactly. So now let's check this. I can say the common ratio here is a second term over fourth term, or we can have third term over second term. So if I substitute, so the second term we have here is 5. That's going to be 5 over 1. Third term we have here is 25 over 5. So of course, this is going to give us a 5. Either we apply the first one or we apply the second one. So 5 is common ratio. If it's a sequence, exponential sequence to be precise, is going to give us the same result. Let's take a look at this past Q and check a question from here. If you want that, we haven't applied the formula itself. That's a beauty of AP and GP. So let's see a question from here, from these past questions. They said, the question says that they said find B if the three consecutive terms of a GP are B minus 4, B, B plus 5. So we have to find the value of B. Even in the options, we are given the option here. They say A is 30, B is 24, C is 20, D is 22. So now we have to find the value of B. So we follow the same process. Let's look at the term we are given. We are given B minus 4 to be the first term. We are given B to be the second term. We are given the B plus 5 to be the third term. Just like the way we normally find our first term, this is the first term, this is the second term, and this is the third term. So now we can see that each term is in terms of B, but it's very simple and straightforward. We follow the same process. So the first thing that we do, I know this is my first term, this is second term, and this is a third term. So here I can quickly use the formula to find the common ratio to obtain the value of our B. So by putting that, I know that common ratio is equal to second term over first term, and which must be the same times a third term over second term, right? So by putting this, that means what we are saying is a second term over first term must be equal to third term over second term. So now let's just substitute the value that we have. What do we have for the second term here? Yes. So the second term we have here is B. all over. What do we have for the first time here? Yeah, exactly. We have a b minus 4. And what do we have for the third time here? You can see the third time we have here is what? Yes, exactly. We have b plus 5. And what do we have second time again? We have b. So you can see now what is the next step here is to cross multiply. That means you are following just to cross multiply because you are trying to obtain the value of b. So if you cross multiply, meaning what we have here, we multiply each other. This one too, we also multiply each other. That is b minus 4 and b plus 5 is equal to b multiplied by b. So by expanding this term, b times b, we have b squared. B times 5, we have 5b minus 4 times b, and we have minus 4b minus times plus. We have treated on how we can make use of expansions, at the same time how we can make use of sign. Please, if you missed our previous videos, go back and watch them, how we can make use of the sign when we have a minus and minus, when we have a plus and a negative, or positive against negative. Now, so here, so if I have minus 4 multiplied by plus 5, just like minus times plus, so here we are going to have minus, then 4 times 5, we are going to have 20 equal to b multiplied by b. Of course, we are going to have b squared. So now here we can have this one to be b squared. Now, let's look at this now. So 5b minus 4b, we are going to have 1b. And in mathematics, we have 1x is nothing but x. So now if you have 5b minus 4b, of course, it is something as just 1b. Then minus 20, everything is equal to b squared. You can see, if you look at the both sides, we have b squared here, we have b squared here. We can use cancellation law by collecting the like terms. That is, bringing the one with b to one side, then with the one without b to the other side. So here, so if you collect the like terms here, that means that we have b squared. Now, you can see, you can arrange it anyhow you like, then plus b. So this is positive. So when the positive comes to this side, of course, it's going to become minus equal to, we don't have anything left here, just like we have 0. Now, what we have here is minus 20. So when the minus 20 comes to this side, of course, it's going to become positive. So now, b squared minus b squared. What is b squared minus b squared? Are we going to have 2b squared? So don't confuse about that one. I've already, if you missed the previous video, I've talked about how to deal with index and exponential, how to deal with them. So when we have b squared minus b squared, it's like when you hold someone, let's say 5, and you want to give them 5. Of course, if you pay, do you have anything left? Of course, it's going to be 0. So that means if I have, for example, let's say I own Made Academia, maybe I own them like 20,000, and I pay it back. Did I have anything left? You see, of course. So now, if I have b squared minus b squared, that's going to be 0. Then what we have left is b equal to, so 0 plus 20, of course, we are going to have 20. So that means the value of b is equal to 20. So now, that means the correct option is, you can see, even without even going deep to that GP, we can make use of the geometric common ratio to find unknown value in a given terms. So now let us go back to how to find general terms of geometric projection. You can see that this topic is very interesting. Just follow, then you get a lot of exercises and a lot of examples. Now, general terms of geometric projection. So just like that one, that one too have a general term. Can you recall the general terms of AP? Yes, exactly. Which is Tn equal to A plus n minus 1d. So please, we said if you check our material, you see how we derive these formulas. So just like that, we also have derivation of this. So you should check our materials. All the materials, subscribe to our channel. You can see how we derive all these formula. So general term of the GP, that one too is given as Tn is equal to AR n minus 1. Please take note of this. It's not AR of n minus 1. No. What we are seeing is exponent. It's in form of exponent. It is AR raised to the power of n minus 1. So this formula, we call it general terms of of a GP. So in under AP, I make some expansions. How you can write the first term, second term, third term, fourth term, as far as any term is concerned. So here too, we also have how to find that. For example, maybe I want to find the first term. I want to find the first term, meaning when the number of term is 1. So by substituting this, I can have T1 is equal to AR 1 minus 1. T1 is equal to AR raised to power over 0. We know anything raised to power of 0 is going to give us 1, right? So now that means here we have A. You can see our first term is A. So if I want to find the second term too, by saying the number of term is 2, if I put it there, that means that we have T2 is equal to AR 2 minus 1. That is when the number of n is 2 now. So by putting this, that means I can have T2 is equal to AR 2 minus 1. Of course, we are going to have 1, or this is the same thing as AR. So now, if I want to find the third term as well, just substitute the same substitutions. Let's say I want to find the third term when the number of term is 3. If I go to that formula, Tn equal to AR n minus 1. So meaning, in the third one now, we want to put the value of n to be 3. So it means you are going to have AR 3 minus 1. That means we are going to have AR 2. So you can, if you find something logically, if you take note, you can see the first term is A, second term is AR, third term is AR squared. Can you guess the following term? Yes, that is going to be AR3. That means logically it's just increasing by 1. You understand? So like, okay, for example, if I said 10th term now, how can we write the 10 terms? Can you give me how can we write the 10 terms? Yes, so that's going to be AR9. Just like the term is reducing by 1. By 1. If I say let's say we are asked to write a term for 1,000. How can we write the terms of 1,000? So that's going to be AR raised to the power of 999. So anyhow we have the terms, just reduce it by 1, then the term will continue. You understand? So far we have the general terms of finding the GP. So we know A represents the first term, just like what we have in the AP, and we have R, that is a common ratio, and we know that N simply means a number of terms. So let's see some examples. Let's see some beautiful example, then we make use of how to apply the formula. So example 1, they said, given that 2, 4, 8, 16 are in geometrical progression, find the 6th term. We have to find the 6th term here. The term 6 over here. That's what we have to find here. So we still the same thing. Just follow the same process. So I told you the first thing we are going to do is to find our first term, as well is to find our common ratio. So let's check this one. What's going to be our first term here? So solution. So let's check what's going to be our first term. So what's going to be our first term here? Yes, that's going to be 2, of course. This is first term, this is second term, this is third term, and this is our fourth term. So now I want to firstly find the first term. So here I can see in the given sequence, my first term is given as 2. Now I want to find the common ratio as well. I know the common ratio is going to be second term over first term, or is going to be third term over second term. I told you any of these you use. So 5, the sequence is going to satisfy the condition. So now I can say the second term we have here is 4 divided by 2. Then we are going to have 2. So now we are asked to find the 6th term. How can we write the 6th term? Yeah, you got it right. So 6th term you're going to reduce by, that's going to be AR5. So that means I want to find when the number of terms is 6. So applying the general terms formula, that's going to be Tn is equal to AR n minus 1. So that means that we have T6 equal to, this is just nothing but AR5, because if your number of terms is 6, that's going to be 6 minus 1, and that one is AR5. So what do we have for first term? Our first term is 2. That's going to be 2 multiplied by our common ratio. What do we have for the common ratio? It's also 2. That's 2 raised to the power of 5. So this is another problem that students used to find it difficult. They don't know how to multiply ratio powers. Like if you look at this, 2 raised to the power of 5, that doesn't mean 2 times 5. It doesn't mean 2 plus 5. Meaning you have to multiply 2 in how many times? That means you are following 5 times. Meaning, this simply means 2 times, multiply 2 in 5 times, 2 times 2 times 2, 1, 2, 3, 4, and 5. So let's just show this ones and take the result. 2 times 2, of course, that's going to be 4. 4 times 2, that's going to be 8. 8 times 2, that's going to be 16. 16 times 2, that's going to be 32. Then 32 times 2, that's going to be 64. So that means here, what we have is 64. So that means our sixth term is equal to 64. So any of these two, you will be asked to find any of these two, either to find the Fox term or either to find the common difference. It depends on the problem. So let me just recreate the same problem and use this to find maybe Fox term so that you see the picture of mathematics here. Let's assume we are to solve a problem like this. They said if the sixth term of an AP, of a GP rather, of a geometrical projection is 64, find the Fox term given that the common ratio is 2. The same problem, I recreated in form of a word problem. You know, I treated a lot of questions under the AP concerning the word problem. So I want to use the same logic here. You know, if I use this, it's something like this, right? So that if I solve it, I'm expecting to have 2 as the result. So let's just follow it. If the sixth term of a geometrical projection is 64, so how can we write sixth term? Yeah, so then if I want to write the sixth term now, it's going to be AR5, or literally I can say T6 is equal to 64. So meaning AR5 is equal to 64. Now, they now say find the Fox term, meaning we are asked to find the Fox term given that the common ratio is 32. So that means if our R is equal to 2, according to what we have here, so that means I can have A 2 raised to the power of 5 is equal to 64. You know, 2 raised to the power of 5 simply means you have to multiply 2 how many times? Yeah, 5 times. And we have done that already. We said this one is the same thing as 32 equal to 64. So since I'm looking for A divisible by 32, that means A is equal to 2. You can see either the question comes in form of word problem or it comes in form of a sequence. Just follow the same method, then you are going to have your result. You know, if you recall, we talked about some examples under that of AP when the value of A and common difference is not be given, and we said that one will lead to simultaneous equation, if you remember that. So in this case too as well, we can have some problem that can lead to simultaneous, but mind you, the way we are solving simultaneous there is not the way we are solving simultaneous here. You know, this one here is dealing with powers. That is, we are having the problem in form of exponential. You know, that one, I told you that we can use either elimination method, use substitution method. Even mathematics is even more interesting. In maths, we have like almost 500 method. There was Jordan, Gauss elimination, like that. There are many aspects. But here, under the GP, we can also have simultaneous. But that one will be in forms of exponent. Will be in form of exponents. So that one will be in form of exponent. Now, so how are we going to tackle that? In that situation, you just consider the two equations. Consider the first one, consider the second one. Then you will divide the lowest one by the highest. For example, let's say I have 2 in the first one, for example, then I have 5 in the second one. You can see this is bigger than this. Just divide the smaller one, let's say between 5 and 2 now. If I want to find the ratio of this, I can say 5 over 2. So please do not use the other, you say, let me apply elimination, let me apply. No. In this particular geometric projections, we cannot apply what we call elimination method by comparing the coefficients. So here we are dealing with exponents. So follow me so that you can have more knowledge about that. Now let's look at this example. They said if the third term of a geometrical projection is 8, while the fourth term, is 16. Find the value or calculate the value of must go 1 common ratio, which is R. Must go 2. We are asked to calculate fourth term, which is A. And as well, maybe let's add one more. Maybe you have to calculate, let's say, 100 times. You can see this term now is much, 100 times. So it doesn't matter. So now, now if you look at this question, you can see we are not given the fourth term. At the same time, we are not given the common ratio, meaning we are looking for two unknowns. So since it involves two unknowns, we are going to have simultaneous equations. So let's go back. If the third term of a GP is 8, so can you remember how we write the third term? Yeah, so that means for third term, let's first interpret it. Third term is given as 8. So, and the fourth term is 16, meaning the fourth term is 16. So now I can easily interpret this. Third term is nothing but AR square equal to 8. How do I find this? I've already told you that. I have the formula Tn AR n minus 1 when the number of terms is 3 now. When n is 3, that's T3 equal to AR 3 minus 1, which is AR square, right? So this is my first equation. So the second equation is fourth term equal to 16, meaning that's AR3 equal to 16. This is our second equation. So we are now asked to find the common ratio. You can see here, I cannot be using the elimination here because this is in form of exponential. It's also simple. So let's consider the first one, the first equation. You can see in the first equation, we have AR square, right? Look at this number. Just ignore the numbers. Consider what we have at the left-hand side, not numbers. You understand? It doesn't matter what we have at the left-hand side. What we are interested in is to compare what we have at the left-hand side. Which one is smaller and which one is bigger equation. So if I look at the first equation, what I have there is AR square. And if you look at the second equation, what we have there is AR cube. So if I ask you now, between these two, which one do you think is the bigger? Yes, because why is it like that? If you look at the first one, we have A, we have A. But in the first one here, we have R square and we have R cube, meaning equation 2 is bigger than equation 1. So that means I have to divide this by this. How? Divide equation 2, the bigger one, by 1. So how? What do we have in equation 2 now? Equation 2 is AR cube equal to 16. So divided by AR square is equal to 8. That is the bigger one over the smaller one. So now, using divisions, A can cancel A here. If you have R cube, it means 3R. R over R square means R. So if R cancel R, how many R do we have left here? Yeah, we have 1 R. That means here we have R equal to 8 and 16. Of course, we are going to have 2. You can see we have our common ratio to be 2. Now, I want to find the fourth term now. So if you like, you can put your common ratio into equation 1, or if you like, you can put it in equation 2. Anywhere you put it there, you are going to have the same result. So if you put the value of A into equation 1. So what do we have in equation 1? Equation 1 says that AR square is equal to 8. Now, the value of R, we got the value of R to be 2. So let's substitute. That means that we have A 2 square equal to 8. So that means we are going to have A 2 square. That's going to be 4 equal to 8. So now I'm looking for A. So divide 2 by 4, right? Because what I'm looking for is A. Divide 2 by 4. Divide 2 by 4. That means our A is going to be equal to 2. So that meaning here, we have the value of our common ratio to be 2. At the same time, we have our first term to be 2. So we have gotten room figure 1. We have gotten room figure 2. But in the third question, we said we should find it 100 times. You can see 100 is many, right? But even we'll be asked to find 1,000 times. So you just have to follow it the same process. So I want to find Or should I change this one to 1,000 times? So either you change to 1,000 times, just follow the same process. You are still going to get the same result. So I was asked to find the third one. We have to find 100 times, meaning what the number of times is 100. Just what make our problem easier here is that we have gotten A. At the same time, we have gotten the value of R. Those are the most important things here. We have already got the value of R. We got the value of A, so we can make a simple substitutions. So if I do that, let's say we are at Tn equal to AR n minus 1. So if I ask you now, how can we write 100 times? How can we write 100 times? Yeah, so that's going to be AR 99. So let's show it so that you can find it more interesting. That's a T100 is equal to AR 100 minus 1. That's a T100 is equal to AR raised to power over 99. So what we have for A is 2. So I have A to be 2, which is 2 multiplied by. What we have for R is 2 as well, 2 raised to the power of 99. Can I use my I to multiply 2 raised to the power of 99? So let me find my brother here with his calculator so that you can press it. So if you have the machine, just check, because you can see 2 raised to the power of 99, meaning I should multiply 2 in 99 times. That is 2 times 2 times 2, just like 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32, 32 times 2, 64, 64 times 2, 128, 128 times 2. You can see my brain is becoming something else. So since I have machine, you can just press it. So that means I can have, so here you can have this brother to be 2 times 2 raised to the power of 99. If you use your calculator, what we have is 6388 then times 2 to save our time. Then just whatever you get for the result here, all we have is what I have here is 1.26. It's in form of decimal times 10 to the power of 30. So just press it just to find it more interesting. That's why I have this type of examples rather. So now let's see another questions. Let's see another questions. Apart from this, let's check our past Q so that we can have more interesting questions from there. Let's look at this. Sorry about that. Love holding all this. Yeah. They said, let's look at this equation from the past Q. They said that the first, second, and last term of a geometrical progression of an exponential sequence are 162, minus 108, minus 21 number 1 over 3 respectively. Find the number of term. Find the number of term. Just a packaging. You can just solve it, the same process, the same method. They said the first, when they say the first, they're talking about A, right? The second, they're talking about the second term. This is AR, this is first term, second term, and last term, the last term of that particular sequence, the last term, that one is Tn. The now said 162, meaning the first term is 162, the second term is minus 108, and the last term is given as a minus 21 number 1 over 3. The last term of that particular sequence is given as a minus 21 number 1 over 3. Since I have the first term, I have the second term, easily I can find my common ratio, because I know that common ratio is equal to second term over first term, and that's going to be minus 108 over 162. So if I do this, I think if you redo this one, you are going to have 2 can go into 2 of them, so 2 over 3, or if you like, use a machine to check that. 1 over 8 divided by 162, so that's 2 over 3. You can see that The value makes sense. Now, so after getting the common ratio, and now from the question itself, we have our Fox term. Our first term that we have there is a 162. So I have the Fox term to be 162. So now, what I want to find now, I was asked to find the number of terms. So let's apply the formula. So we have already got our common ratio now. So let's write the data. Any problem? Yeah, it's working perfectly. I think. Yeah, it's working. So now, so let's write the data now. So that means our first term is 162. So what we get for the common ratio now, we have the second term of our Fox term, that is minus 108 over 162. We have it to be minus 2 over 3. And in the problem, we are given that last time is minus 21 number 1 over 3. So meaning I can just change this one to mixed fraction, to improper fractions. So 3 times 21, and we have that one to be 63. Then plus 1, and we have it as minus 64 over 3. So now, what we are asked to find is the number of terms. That means I'm looking for n. So applying the formula, we have Tn is equal to AR n minus 1. You know, this is our usual formula. So what we have on the last term is this. We have minus 64 over 3 equal to my Fox term is 162. Our common ratio, what do we have on the common ratio? Common ratio is minus 2 over 3 raised to the power over n minus 1, because the value of our n is unknown. So now, since I'm looking for this, you can see this is 1/2 n. I can firstly divide all through by 162 so that I can reduce this term. Divide all through by 162 divided by 160. So if this cancel this, I can have this one to be minus 64 over 3 divided by 162 is equal to minus 2 over 3 raised to the power over n minus 1. You know, remember the law of reciprocal. If you have division between two fractions, how can we deal with that? You know, when we have division between two fractions, division sign will change to what? We change to multiplication. So meaning if I have a over b divided by d over c, I can change the sign that this one can be a over b, then this move up, then this move down. That means that we have c over d. So that's what I'm trying to apply here now. You know, if I have 162, it's nothing but 162 over 1. So by changing this, I can just have this one to be minus 64 over 3 multiplied by 1 over 162 equal to minus 2 over 3 raised to the power over n minus 1. So there are one number that can go in 64 and 162 without remainder, right? So 2 can go, of course. So 2 in 164 and we have 32, right? So in this, we have 81. Cool. So now what we have left now here is minus 32. Then 3 times 81, we are going to have 243 equal to minus 2 over 3 raised to the power over n minus 1. So let me make use of this side so that I can have the beauty answers. So now, so you can see what we have now is minus 32 over 243 equal to minus 2 over 3 raised to the power over n minus 1. Clearly, it's leading to something like indices. That's the beauty of mathematics, from one topic to other. So now we are under GP now. We are using indices now. So meaning, what number how many times can I multiply 2 to get 32? And how many times can I multiply 3 to get 243? So let's check. If I have 2 times 2, are you with your machine? So be checking, please. So 2 times 2, that's going to be what? 4. 4 times 2, that's going to be what? 8. 8 times 2, that is 16. 16 times 2 is going to be 32. That means how many times here? That's 2 raised to the power of 5. So that means I can write this as minus 2 raised to the power of 5. If you multiply 3 to in 4 times, in 5 times rather, you are going to get the same result. 3 times 3, that's 9. Times 3, 27. Times 3, 81. Times 3, 3, 243. So that is 2 raised to the power of 5 over equal to minus 2 over 5, minus 2 over 3 rather. We have minus 2 over 3 raised to the power of n minus 1. So now you can see under indices as well, if they have the same power, we can just factor them out. This is the same thing as x over y raised to the power of a. So that's what I'm trying to apply now. You can see the first one have a power of 5. The second one also have a power of 5. I can rewrite this as a minus 2 over 5 raised to the power of 5 is equal to minus 2 over 3 raised to the power of n minus 1. So meaning now we can see the two terms are the same. So I can easily cancel them. What we have left here is 5 equal to n minus 1. Just like the way we are doing indices. After the base are the same, we take the power here, we take the power here. So the power that we have here is 5, and the power that we have here is also n minus 1. So what is now the next step now? Yes, so we collect the like time because what we have here is minus 1. So we know if the minus come to this side, we are going to have plus. That means that we have 5 plus 1 is equal to n. So meaning our n is equal to 6. That means the number of terms that we have in that particular problem is 6. You can see. So you may be given anything in this area. Maybe you are given the common ratio. You may be asked to find the first term. Just solve it the same process. Just follow the same pattern, and you can have your result. So just like the way we have some under arithmetic progression, we also have some under geometric projection. Even we still have what we call sum to infinity. We are coming to that. So this is made easy academia. We have quality things, even many examples. If you even check our material, you can solve as many exercises as you like. So no matter how they bring the problem, you can be able to tackle it and solve that particular problem concerning either AP or GP, sum of GP. But before that, there are some problems that will come in form of sum without using this formula. So let's take a look at these past questions. Then we now solve the two together. They use the word sum here. Look at this question. In a geometrical progression, the sum of the second and third term is 6, while the sum of the third and fourth term is minus 12. Find the first term and common ratio. Find the first term and common ratio. You can see in this problem, they use the word sum. So this doesn't require for us to use the formula. You can just make use of that and check if it's going to work. Now, let's check. In a GP, you know they use the word sum. The sum of the second and third term. So let's firstly write the terms, We know first term is A, right? Second term is what? We have done that one before. Second term is AR. Third term is nothing but AR square. Fourth term is nothing but AR cube. I've told you how to express that, right? Good. So now, then also the sum of the second, that is the second is AR, and the third, AR squared. They said if this is equal to 6, this is our equation 1. So before you go for that, check, do we have anything in common between these two terms? Of course, we have something in common. That means we have AR in common. You can see this is A here. It also appears here. I have R here. I also have R here. So that means I can have AR bracket over, if I factor that R now, what are we going to have left here? I'm going to have 1. No, this is R squared. If I factor out AR out, that means I will have 1 R left, right? Do you get that? Or I should come back again to explain this. Check the first one here. I have A here. I also have A here. So I factor that A out. This is A here. So meaning I have R here and I have R squared here. That means the R is also common. So I factor that R also. So that means what that we have left is R now. That's 1. If I have AR over AR now. So this is 1. Second one, AR square over AR. If A cancel A, R square in R, that is R over R. That's going to give us R. Then everything is equal to 6. This is our equation 1. You understand? Still the same thing. So the second one, they says that The third, if I want to write the third now, as a r square, and the fourth, that's a r cube, right? So equal to minus 12. Of course, I will still follow the same process, the same pattern. This is my equation 2. Let's factor what we have in common. So here I have a, and at the same time, I also have r square. So that means, what are we going to have left here now? Yeah, and we have 1, and we have r here is equal to minus 2. So I can say this is my equation 2. So now we derive equation 1. At the same time, we derive equation 2. So what do we have for equation 1? Equation 1 says that AR bracket of 1 plus R is equal to 6. And equation 2 says AR square 1 plus R is equal to minus 12. So you can see it's very simple and straightforward. Nothing difficult here. Now, so what is equation 1? Equation 1 is AR bracket of 1 plus R is equal to 6. This is equation 1. Equation 2 is AR square 1 plus R is equal to minus 12. So now, so as I told you, it's not like we are going to use elimination. Check which one is bigger than the other. You can see equation 2 is bigger than, I told you, don't consider the one we have on the left hand side. You know, if you consider them number by number, you can see 6 is bigger than minus 12, right? But we only consider them in terms of their exponential power. So divide 2 by 1, since 2 is bigger than 1, right? So that is AR square 1 plus R is equal to minus 12 divided by AR 1 plus R is equal to 6. So now, of course, you can see this and this are the same, right? So if this eliminate this, you can see A can also eliminate A here. What we have left is R square, and what we have here is R. So now if I have R square over R, is nothing but R. That is R is equal to minus 6 and 12, and we have 2, meaning our first time, our common ratio is equal to minus 2. So I can put the value of common ratio into either equation 1 or equation 2. We are going to have the same results. Which one do you want us to pick? Okay, anyone. Let's just pick anyone. If I put R, or substitute the value of R into 1. What we have equation 1 is AR bracket of 1 plus R is equal to 6. So now the value of R is minus 2 now. So if I substitute, that means that we have A, then minus 2 plus 1. Here, let me write this very well. 1 minus 2 equal to 6. So now if I can have A times minus 2 here, I can have minus 2A. You know, if I have 1 minus 2, I should check if it is working. Yeah, I want to check. Yeah, it's working. If there's any problem. So now 1 minus 2, of course, we have minus 1 equal to 6. So we can see this is negative. This is negative. So minus times minus, we know that was going to be plus. And we have 2A equal to 6. So divided by, both side by 2, since I'm looking for A, right? By 2, meaning our A equal to 3. So that means the first term is 3, and the common ratio is minus 2. So let's go to some of GP. I told you, so if you check our materials, you will see how we derive the formulas. So in order to save our time, so it's of two cases. First case, when your common ratio is greater than 1. The second case is when your common ratio is less than 1. So if it is greater than 1, we have a formula for that. If it is less than 1, we also have a formula for that. How? Let's say some of GP. First one, xn is equal to A r raised to the power of n minus 1, 1 r minus 1. This can be applied when our r is greater than 1. Meaning, if I'm solving a problem and I see that the value of my r is bigger than 1, you understand? If it's bigger than 1, of course, I will apply this formula. But if the value of my common ratio is less than 1, then we apply this formula, xn equal to A. So instead of having this, we just switch them. That's going to be 1 minus r raised to the power of n. Then since we switch this also. 1 minus r. This one is if r is less than 1. So two cases, please. So you should take note of that. If you are solving any problem and you see that the value of your r is bigger than 1, meaning maybe you get like 2 or 4 or 6 or 8, then you are going to apply the first one. But if you are solving a problem and you see that the value of your r is less than 1, meaning maybe it's like minus 2 over 3 or 2 over 3 or 1 over 3, that means the value is less than 1. So if it's less than 1, we are going to apply the second one. So it's based on the value that we have for the common ratio. So let's see some examples of that. Let's see some examples. Okay, let me just write it here. They say given that 1, 3, 9, 27 are in geometrical projection, find the sum of total. So let's look at this. So I will follow the same process. So here the first term is 1. So I can just, this is the term given to us. We have our A. This is the first term, this is the second term, this is the third term, and this is the fourth term. So my first term here is 1. So I want to find the common ratio, the same process as a second term over first term, or I can say third term over second term, or just like that. So here I can have 3 over 1. So meaning our common ratio is equal to 3. So now we have to find sum of third term. It is when the number of term itself also equal to 3. So I can just apply the formula. This is xn. Now if you look at this, you can see r is bigger than 1 because what we have for r is 3. So since r is bigger than 3, we are going to apply the first one. So we have xn equal to a bracket of r raised to the power of n minus 1 over 1 minus r, right? Over r minus 1 rather. So here I can have x3, sum of third term, equal to, so our a is 1, it is 1, bracket of our r is 3, 3 raised to the power of, our number of times we have to find is 3, minus 1, all over, our r again is 3, 3 minus 1. So here we have 1 bracket of 3 raised to the power of 3, 3 raised to the power of 3 means we should multiply 3 in 3 times. So 3 times 3, we have 9. 9 times 3, that's going to give us a 27 minus 1 all over 3 minus 1. That's going to give us a 2. So here I can have 1 bracket of 27 minus 1. Of course, we are going to have 26 over 2. This 1 times 26. That one is nothing but 26. Then 2 in 26, we are going to have a 13. So if the value of your r is less than r, you are going to, is less than 1, you are going to apply the second one. If we still have another one called sum to infinity. So let's add that one too. Sum to infinity. Sum to infinity. When you say infinity, what does that mean? When things has no ends. So sum to infinity. In mathematics, we use this symbol for infinity. Sum to infinity. When a term is continuous. So sum to infinity. That one is this. A over 1 minus r, because in this case the value of your r will be always less than 1. So sum to infinity is always given as a. A is first term divided by 1 minus r. So let's see some problem from here. Let's see a problem from here when we have to find. Okay, let's look at this one. They said find the sum to infinity of the series 1 plus 3 over 7 plus 4 over 49 plus 27 over 343 plus 81 over 2401. So we have to find the sum to infinity for this problem. I can follow the same process and the same pattern of this, and how are we going to get that? So let's see how to solve that. I hope you are following right. I don't mind if there's code. So we are just trying to manage our time. So now let's look at this sequence. We have the first term. The first term we have here is what? There is 1. So here I have the first term to be 1. It's just like a series. The first term is 1. So as usual, I want to find the common ratio. That's going to be the second term over first term. Just like this is the first term, this is the second term, this is the third term, fourth term, like that. So that means here we have second terms are 3 over 7 over 1. So we are lucky here. It's still going to remain as a 3 over 7. So I want to find the sum to infinity. Sum to infinity is equal to a over 1 minus r. So sum to infinity is going to be equal to, my first term is 1 divided by 1 minus, my common ratio is 3 over 7. So here we have 1 over. So by putting the value of this, we have 7 here, right? So 1 in 7, that's going to be 7. 7 times 1, that's going to be 7 minus 3. So you are going to have this one to be 4 over 7. Law of reciprocal is going to be 7 over 4. So now this is what we just call sum to infinity. It's different from that of sum to GP. If it is GP, I say it's of two cases. If the value of your R is bigger than 1, we apply the first one. If the value of your R is less than 1, we apply the second one. But sum to infinity is just x to infinity is equal to a divided by 1 minus r. We still have another one. Let's add more ingredient to this. We still have another one called geometric mean. I taught you arithmetic mean the other one. So here too we still have geometric mean. Just a simple substitution. We have many ways of doing that, but in a nutshell, what is time? What is time? Okay, so let's just finish it. So now for geometric mean, we also have, just like the way we have arithmetic mean, we also have geometric mean. Just like insertions. So insert the time between two given numbers. Just like the way we do it earlier. Let's just solve one question so that it will be like a bonus. This is okay. Before that, let's look at this problem. It's coming in form of alphabet. Look at this. Before that, let me solve that as a bonus for you. They say find the nth term of the GP QQ P square Q5 PQQ7. Don't mind them. It's simple and straightforward. Don't have to worry. You see the same process. Here I can find my Fox term. My Fox term here is a QQ, right? So I want to find the common ratio. Common ratio is a second term divided by first term, right? So the second term we have here is a P square Q5 divided by the first term we have is a QQ. So here I can have P square, this is Q5, Q3. In this is 5 minus 3, we are going to have 2. So the next step is to find the nth term, which is our general terms of that particular GP. We know the formula is Tn equal to ARn minus 1, right? So down here we have Tn equal to, my first term is QQ. My common ratio is P square Q square raised to the power of n minus 1. So I can just open the bracket with this. Down here we have Tn equal to QQ. If I open the bracket, we have P. This one that we have outside, meaning it affects the two terms that we have in the bracket. So 2 times n, and we have 2n. 2 times 1, and we have 2. Q raised to the power of 2 times n, and we have 2n. 2 times minus 1, and we have 2. Just like indices, product law. What we have outside the bracket, we affect the exponent power that we have inside the bracket. 2 times n, I have 2n. 2 times minus 1, we have minus 2. 2 times n, we have 2n. 2 times minus 1, we have minus 2. So with this, we can see something is common. So what do we have in common that have the same power, the same base? You can see this and this have the same base. I can have this one to be P raised to the power of 2n minus 2. Then Q raised to the power of, if you check this, you can see this and these are the same indices. So that means I can have this one to be 3 plus 2n minus 2. Just like I had their power together. This plus this plus this. So that means here we have Tn equal to P raised to the power of 2n minus 2, Q raised to the power of 2n, then plus 1. You can see how we have that. We have that one to be our main result. Now, so let us go back to this geometric mean to solve it as our last examples. They said, under the geometric mean, just like insertion between two given terms. Let me see if I can have a problem from that. We asked to insert. I think we are going to have a question from there. Okay, we have a question from there. They said, from here, we said, so let me check if this brother is working. Yeah, it's working perfectly. I can hear me clearly. They said, insert I hope you can see my handwriting. Don't mind my handwriting. Insert 3 geometric mean between 4 and 1/4. So now this is a problem. We have to insert 3 geometric mean between 4 and 1/4. You know, I told you we don't know the actual numbers they're talking about. I can just use any alphabet. I can say let x, y, and z be the 3 geometric mean, right? So between these numbers, that is 4, the first one, x, the second one, y, the third, z. Then the last we have it to be 1/4. You see, it's a geometric projection. Now, these are our first term here. So our first term, as usual, this is second term, this is third term, this is fourth term, and this is our fifth term. So now my first term here is 4. You can see the second term that we have here is in form of alphabet, not a number. So, but I have the number of terms to be 5. This is 1, 2, 3, 4, 5. Then at the same time, I can have my last term to be 1/4. So if I apply the formula, that's a Tn equal to Arn minus 1. So the last term we have here is a 1/4. That one is a 1/4 is equal to our first term is 4, right? We have 4. Common ratio is what we are looking for. Number of times we have is 4, 5 minus 1. So I can just divide both sides by this to make my problem more easier. So this one can just give us 1/4 times 4 here, just like this. 4 times 4, we have 16. R raised to power over 5 minus 1, that's going to give us 4. So I'm looking for R. So what can we use to cancel? If you have a square, what can we use to cancel square? That's going to be square. So if you have 4, the only thing you can use is to 4 through the both sides. Meaning, what number can we multiply in 4 times to get this? Of course, that one is for 1. Then, what number can we multiply in 4 times to get 16? That's going to be what? Yeah, exactly. That's going to be 2. That means our common ratio is equal to 1/2. We have already simplified the problem. We can see x is the same thing as which term? Yes, exactly. X is the same thing as second term. I will leave these two for you to try. Then second term, x is the same thing as second term here, right? So which is second term is nothing but AR. So my A is 4. That's going to be 4. Multiply our R is 1/2. Then 2 in 4, we are going to have 2. So you try for y. Y is the same thing as which term? That's third term. Very nice. Then Z is the same thing as fourth term. So this comes to end of AP and GP. We discuss about sequence and series. We talk about arithmetic progression. I told you that arithmetic progression is also the same as a linear sequence. We talk about how to find the sum of an AP, arithmetic mean, how to find geometric mean, at the same time the sum of geometric mean as well, the sum to infinity. So please subscribe to our channel so that I can have more videos. So thanks for watching, and don't forget to share, likes, and subscribe. I think this comes to